Okay, so welcome to this final lab, and it is called periodic motion and resonance. So periodic motion is a motion which repeats itself in regular interval of time, and we will see that practically here. So it has two parts, and in the first part we have this mass spring system, we have a glider, and we will give you the mass of this glider. So initially what we do is we measure the relaxed position or the equilibrium position of this mass spring system. So I remove all the weights from here, and the relaxed position is like 166 centimeters. Then what I do is I put on some weight on this hanger. So we have to be careful to include the mass of the hanger as well. So when I put on some weight here, I can see that now the mass spring system has stretched by 1 centimeter. So basically in the lab manual, in the lab report, you have to mention in the table the relaxed position, the stretched position for different masses. And then we have to take the difference of the equilibrium position and the stretched position, and that would be the displacement of the spring. So next what we have to do is we have to find the force, which is basically the weight, and we can calculate it from F equals to M multiplied by G, where M is the mass on this hanger, including the mass of the hanger. So then what we do is we have to plot the displacement against the force, and that will give us a straight line. We have to fit a straight line, and the trend line equation will give us the value of the spring constant. So it is very important we get to know the spring constant of the spring, and that we will use in the second part of the experiment. So for the second part of the experiment, I remove the mass from the glider, and I attach a frequency generator with this setup. And we have to make sure that the glider is not touching this stand. Okay, so I turn on the frequency generator, and it has a range of frequencies, so you can see the frequency here. Now the next thing which I do is I will increase the frequency from 0 to the maximum, and at the same time we will turn on the air blower to reduce the friction. So now you can see that the mass spring system is vibrating, and around a specific frequency the vibration will be maximum. It means the amplitude is maximum. And if you cannot see it from the naked eye, I can put the card close to here, and that will tell me if the amplitude is increasing with frequency or not. So once we know that central frequency around which it vibrates the maximum, or the displacement is maximum, then what we do is we take 10 frequency points beyond that frequency or above that frequency, and 10 frequency points below that frequency. So the point is to plot a curve of the frequency against the amplitude. So once we plot that curve, that will give us the resonance frequency. So now basically we have two resonance frequencies, or I should say resonance frequency from the experiment, which is the frequency for which the amplitude was, or the displacement was maximum. Okay, So that is our experimental value, what we read from here. And then we have to use the equation, and I told you that we have to take the K from the first part. So basically, your lab manual, it mentions an equation in which you have to use the mass of the glider and you have to use that K value to find the theoretical resonant frequency. So that would be your lab, and then based on these this experiment and the data which we will provide you, you can answer the questions and do all the analysis.